Hey guys, just want to talk to you about a couple new features that came out with the Storyboard 5.2 release, the event editor, the Storyboard Connector, and the header export. We always talk about creating a strong architecture by separating your UI from back-end logic using Storyboard I/O. With these new pieces, you can now create that story a little bit easier. To start off, the event editor is a new view that allows you to define your events. You can then pass those events into the Storyboard I/O connector and inject them directly into your UI. This means you no longer have to go to the command line to inject content or write a simulator. You can use it directly from the design tool. Finally, you can then generate a header with our event header export feature, and you can now share that with the engineering team responsible for your backend. That way everyone's on the same page, and you can be sure that content coming from your backend to the UI is consistent. With that, let's jump into the tool and see what this feature looks like in practice.
So we have our cluster sample here. This UI simply has a single screen and a couple dials and pointers that can be rotated, as well as gauges for gas and oil, as well as battery level. To do anything, we need to get an event into the UI. And you can see that we already have a cluster update event set up that calls back to a Lua script, which then does some data injection and modification. If we open up our event editor, this is one of the new features, you can see that this cluster update event has some data described with it already. So you can see that we're going to be expecting speed, RPM, fuel, battery, oil, odometer, trip. Values like that can be coming in with this event. We've already set some min and max values, as well as provided a bit of a description. Because we've done this, the other feature, the Storyboard Connector, can then read this information and provide a mechanism for us to inject events into the UI. So here you can see that we have options for now injecting speed, RPM, fuel, battery, oil, odometer, trip. And what this looks like, if we just simulate our application here, is I can then now drag these controls and in real time inject data into the UI. RPM, fuel, battery, and oil. And what this means is I didn't need to deploy my application on the embedded system. This saves me a lot of time because I can very quickly and easily debug logic. Say the gauges weren't updating properly or they were moving past their bounds. I wouldn't be involved in the costly cycle of re-exporting and deploying to the embedded hardware. Again, this can all be done from my development environment where I'm able to quickly iterate and fix problems and resolve issues. The other nice feature is we can very quickly create new events and new content. So if I wanted to create an event to say toggle these indicators, I can go ahead and do that with the event editor. Add an event. I'll create a new event called indicator. We can specify a direction if it's coming into the UI, if it's going out, if it's just an event that we generate in the UI and self-consume. In this case, it'll be coming in from a back-end system. I'm just going to add a description here. And then we can start associating data with these event payloads. It makes sense that since the indicators are on or off, that we treat them as small data values to be a little bit more efficient. So I'll select a 1 byte unsigned integer. I'll give it the name left to represent the state of the left indicator. Say finish. Do the same thing for the right. We'll set a maximum value, so treat this as an on or off Boolean type logic. You can see we have our new event that's popped up, the data associated with it, so if we wanted to make modifications to it, and if we hit save, this change will then be propagated back into our UI environment so we can then consume it and do some logic with it. Now I've already created some animations for toggling the indicators on and off, but the first thing that we need to do is actually bind into this new event. So again, if I were to go to our application, add an action, search for a new event indicator, as you can see here. We can feed that to a Lua callback. Select Finish. If we save this, simulate, we can select the indicator event from the dropdown, and now we can toggle the controls on or off. So that's really powerful. We're able to rapidly develop, we can test, and we can iterate, all without having to deploy onto an actual system. The final piece of this puzzle comes in the form of the Storyboard Header export. So we can actually generate a header file that represents the events and the data structures associated with this application. So if we go over, look at our project here, you can right click on your GDE, Storyboard Export, Storyboard IO Event Header, and we have a couple different options. It could be we just want to export the names, formats, or the data structures. I'm going to select all of them, say Finish. We can select our header here if I just open that up. And you can see that has a representation of the events we created, the associated format strings, and the data structures. And this is really good because this allows us to finally bridge the gap between the system level engineers as well as the UI developers and designers. This header file can be that unifying piece between the UI and the backend. We can use this as the event structure that we will always follow, so the UI developers know that they can be free to simulate content based on what's here, as well as this can be embedded in your C++ backend. So again, this makes sure that your backend is using the same structures and the same events and the same formats, and it should help reduce on integration testing. So I know the guys here in R&D were really excited about these new features. We hope that you are too, and we hope you see the value in integrating that into your new storyboard projects. Thank you for your time.